But next up, we're going to hear from Reto Trinkler, who is chairman of crypto asset management platform Melonport. Reto.
Hello, everyone. My name is Reto Trinkler. I'm the chairman and co-founder of Melonport, together with Mona Elisa. I'm a member of the Web3 Foundation. I'm chairman and CEO of Trinkler Software, and been named the Forbes 30 under 30, both in Switzerland and Europe. So my talk is on domain chains, in particular on Melon Chain. So it's really like, it's essentially like building a customized blockchain. And it's really like an alternative way to smart contract security, because rather than custom fitting your smart contracts such that they fulfill the requirements of a blockchain, it's like designing a blockchain such that it's custom fitted to a specific domain, for example, asset management. This doesn't seem to work. Sorry, 1 second. Sorry. Yeah, okay, so overview. I'm going to talk a bit about the corporate structure of Melon Chain. I'm going to describe the essential building blocks of a domain chain. We're going to look at Melon Chain as an example for a domain chain. Then some of our fundamental beliefs at Trinkler Software, that's domain chains, like the rise of domain chains. Then the requirement for a new kind of law. And finally, describing the vision, which is tools for a catalactic society. So the corporate structure. A while ago, in 2016, we set out at Melonport to build blockchain software for asset management. My co-founder and I, Mona Elisa, we worked about 1 year full-time without pay. Was incredibly hard work. Was very exciting. We did a crowd sale in 2017, early 2017, together with our friends from Bitcoin Swiss. And we've since grown the team to 13 people, of which originate from 9 different countries. So our team came from almost all around the world to help us deliver on that vision of a decentralized asset management system, and something we're incredibly grateful for. And we've worked a lot. We essentially solved the main problems. There are still some problems left, but it's an incredibly talented team, and that team, no doubt, can solve the outstanding issues and deliver that asset management platform. So it really frees me up to focus on what is needed. And what is needed is research. So it's like researching how we can improve it. And that's essentially where Trinkler Software comes in. And yeah, Trinkler Software loves Melonport. We're lucky enough to have received a research grant from Melonport, which we now use to research the feasibility of Melon Chain. Both Melonport and Trinkler Software love Melon, so it's a shared vision. We want to see decentralized asset management as it should be, I guess. So it's essentially a division of labor. Melonport will focus on delivering Melon on Ethereum. and my company will focus on the feasibility study of Melon Chain. So again, why domain chains? So it's really a different security approach. So rather than implementing a smart contract system that fits into a specific blockchain, we implement a blockchain that fits into a specific domain. So in this case, it's asset management. So the essential building blocks of a domain chain. So maybe first, what is a domain chain? So a domain chain is really just a specific blockchain, a blockchain for one purpose. Ideally, a blockchain that just does one thing, but does it well. So the building blocks are state, validity, and canonicality. We're going to have a short look into those three. So like we can compare blockchains to some degree to like traditional computers. And the state in a traditional computer would just be, storage, how stuff is stored. And that's similar in blockchain, except for the fact that this time it's shared. It's shared among network participants. The goals of state are to make the state as small as possible. If you have the Bitcoin state, for example, or the Bitcoin blockchain, then it really becomes apparent that it's too large. It's not user-friendly to have to wait days until you downloaded your chain. So it's state really should be as compact as possible. The second essential building block is validity. And validity is really this concept of modifying state. So we start with state, and now we want to change state. And the way we change state is by applying a state transition function. And in that state transition function are all of the essential rules of that blockchain codified. So for example, with Bitcoin, it's just like a basic accounting system, right? With Melon Chain, it's just a basic asset management system. So the main goals of validity is to allow efficient and light state transition proofs and to minimize the amount of proof helpers, meaning you should be able to discard as much as possible, or your validity function should make it possible to discard as much as possible of the unnecessary information. So it's like a cleaning up process. And the last part is canonicality, and that's really new. Like we haven't seen that before in traditional computers. And canonicality is really, arriving at one truth among many possibilities. So if you have state, if you apply a state transition function, then you get a new state, but you can have different outcomes. So meaning, so the input to state transition functions are essentially externally generated user data or transaction. But transactions can be different. There's different kinds of valid transactions, which can lead to different kinds of valid new states, right? We see that all the time in blockchain. It's called micro-forking. So what we need now is a way to come to consensus on which one to use. So the canonicality has as main goal, come to consensus on which validity proof to use, achieving Byzantine fault tolerance, and minimizing networking requirements. So axioms of blockchain design. So if you want to build your own domain chain, then please consider those. So the first one is, please consider those axioms. The first one is, build your blockchain in a way that it does not require trust in third parties. It's really an essential part of what blockchains are, and it's something that was very, very important for Satoshi Nakamoto to remove, central parties. That's really the concept of decentralization. It's remove central parties. The second one is it should be easy to opt out. So if we, if you want to build a new financial system based on open source, then let's consider the mistakes of the past, which are really that we can't opt out. Too big to fail. Like we can't opt out of the current financial system that easily. And the third one is it should be legitimized by consent. It's no different than almost any law of any country are to some degree legitimized by consent. That's how democratic governments work, that they're legitimized by consent. And that's the same with blockchains. They always should be legitimized by consent. Any creature of light should recognize this as self-evidence. Okay, so melon chain. Melon chain is really, an example for a domain chain, for a specialized blockchain. And that's what I'm going to be focused on. So subject to the feasibility study are the main challenges, which are price feed. So we need to have an algorithm that provides canonicality or potentially ambiguous information. It's a non-trivial task. The second one is we need to have an asset management runtime. So that's on Ethereum. That's just smart contracts. On a blockchain, it's a runtime. Luckily, we gained a lot of experience building Melon on Ethereum that we can now port a large degree of that experience into building that runtime. Next one is an exchange as efficient as possible. So ideally cross-chain, custodian-free, cheap, and scalable. And last one, integration into the relay chain of Polkadot. So we want to have native interconnectivity. Okay, so why bother? Why bother building your own chain? It's really this belief of the rise of the domain chains. And goes something like this. So to understand this, we need to have a historical context. And the historical context is, the first wave of blockchains were kind of Bitcoin-like blockchains. So, Bitcoin, we had very similar blockchains like Litecoin. We had blockchains that were just marginally different, maybe just had a marketing spin, Dogecoin. But we also have seen blockchains that were technically different. So for example, Namecoin. Namecoin was really an example of a blockchain that is not just for payments, a blockchain that you can register domain names. So to summarize, with Bitcoin, we've seen the first glimpse of what an open source financial system could look like. We have seen a lot of isolation. So these blockchains weren't able to talk to each other, and they were very specific, very specific to a domain. And what was kind of left over of that first wave was this clear understanding of, big blockchains are meant to play a bigger role. They're not just for payments. The same cryptographic primitives, the same networking protocols, they still apply if you build a blockchain that does something else than just transactions. That was really the introduction of the next wave, which was this concept of Turing completeness. That's kind of the leading example here is Ethereum. So what Ethereum achieved was it removed to some degree this local isolation. So you now could build like a Namecoin blockchain with a couple of lines of Solidity code. You really can build applications that can talk to each other. So an example is ERC20 token. So you have two ERC20 token, you use a system like Kyber, and you can interact. So the takeaway, so the main problem though is this idea was so powerful that after a while this shared general purpose computer was just overused. It was very similar to how computers 30 years ago were kind of shared by multiple people, and whenever someone downloaded some application on that computer, like everyone else also kind of had that on their computers. And that's the same with Ethereum. So its biggest advantage is also, to some degree, its downfall. Another way to visualize it is, like a CryptoKitties user. A CryptoKitties user kind of inevitably is being bothered with everything that happens on the asset management side. And an asset management user is kind of bothered inevitably with everything that happens on the CryptoCity side. So you can't separate. So takeaway, second wave, locally connected, but not specialized, Turing complete. So the main problems to solve are global isolations. So we see the same thing again with Ethereum. Like we have blockchains that are very similar in nature. They might just have like a philosophical spin, Ethereum Classic, or they might just have like a small technical spin, like not small, but they have technical differences like Cardano or similar blockchains. But these blockchains, they can't talk to each other still. And the second big problem is scalability. So we now know they just don't scale. And the solution for this is Web3. It's, you go back to specialization. You have like one blockchain for one purpose, but this time you connect them. So, a CryptoKitties user can now have their own blockchain just for CryptoKitties, and they're kind of, in their own world. But using interconnectivity, they still can switch their CryptoKitties to Melon and vice versa. Yeah, and really, this type of specialization also will help a lot with usability. Like, you can build blockchains that have such a small state or such a small blockchain size that you can download them, in less than a minute in the context of your browser. So that's huge for usability. That's huge for mainstream adoption. And it also allows us to build something that I call autonomous applications, which is really, instead of having like a traditional server, you now have a blockchain. Instead of having like a front that is hosted on some centralized server, you host them on a distributed BitTorrent-like swarm, for example, IPFS. And you can use, you can build in some content monetization, and then use networks like Kyber to like convert those rewards against Filecoin. You use the Filecoin to pay for hosting. So they really become like, they live on its own, these applications. They're almost indestructible. Yeah, so the key takeaway of the third generation is globally connected and specialized. So since we're in Crypto Valley, I would like to talk about some of the requirements, I guess, of a startup. And I think, like, especially in Switzerland, we kind of lost, to some degree, our innovative spirit. Like the latest regulation were not really in favor of young, innovative startups. And it's really like, it's kind of missing the point. Like, new technology requires a new kind of law. And what we've seen, like in most jurisdictions, is we try to apply old law to an entirely new concept. And it's really something that stifles innovation. A really good example for a jurisdiction that does this differently is Malta. So the Malta Financial Service Authority, which is something like its regulatory authority, they were humble enough and professional enough to say, like, this is something we don't understand. This is something that doesn't fit in our concept. So instead of applying old law to a new technology, we just create a new independent regulatory authority just for distributed ledger technology. So this is now a bill that is about to pass in Malta, and it's going to establish a digital innovation authority, and really should serve as a leading example for Switzerland. Because, yeah, as I said, it's getting difficult to set up a blockchain in Switzerland. And finally, would like to talk shortly about Trinkler software and what our mission is. And our mission really is to build tools for a catalactic society. So catalactics is an Austrian economics term, and it means approximately to exchange or to trade, or to turn a foe into a friend. So it's the science of interpersonal exchange, where if someone offers something to trade, the counterparty can reject free of any negative consequences. And that's really what blockchains are, if you think about it. Like you can initiate a trade, and as counterparty, you can reject that trade, that trade or that offer, free of any negative consequences. That's truly how you turn a foe into a friend. And yeah, and this is something I want to dedicate my time on. So call for action, Trinkler.software. We're, for the first time ever, I'm looking for a small equity investment at a very reasonable price. So if you're interested, then you can contact us at company@trinkler.software. If you're a developer, you can check out our GitHub, which is github.com/Trinkler. We have a Discord chat, and we also have a Twitter. Yeah, so finally, I would like to thank Crypto Valley Association for a fantastic organized event. Thanks very much.